point A, B, point C, point D, and point E, right? And if you have a load coming down P in this direction, right? So when you declare it is thrust analysis or doing thrust analysis, okay, all members are under axial loading only. Okay, so i.e. you ignore stresses induced by bending. Okay, you ignore them. So if you look at point A now, right, or we look at member AB, okay? So I'm going to sketch a line. This line represents the neutral axis of member AB in orange. Okay, so I'm going to blow it up. Okay, so this is the neutral axis for member AB, right? And we realize that we have a load P. So this is our A, point A, right? And this is our point A. And at point A, we have a certain load coming down in P. Okay. So if I were to draw our transformation, right? X, Y rotation of the Z. And what we are doing is we are going to apply the method of joints. Right? I hope this is familiar, right? So what we have down here, this is our member AB. Okay, so this is the beam AB, right? And we said that the forces can only be applied along the neutral axis. Okay, so now with the point P down there that's coming up, going downwards, right? AY has to go upwards, right? So this is our AY, right? So we have to prevent point A of coming down. We have to have a reaction known as AY, okay? And so to apply the load in the axial direction, okay, this is our reaction of FAB. Okay, that is our reaction of FAB. Okay, so we know, right, that is the reaction, the resultant reaction, right? So this will be known as our AX. Okay, so I will make this sorry. Okay, I want to draw a smaller arrow, sorry. Okay, right, so that is our FAB direction. Okay, now based on Newton's third law, okay, after you do this, based on Newton's third law, can anyone remember Newton's third law? Anyone?
Is it that every action has a reaction?
Yep, thank you. So action equals reaction. Same in magnitude. Okay, different in direction. Okay. So action equals, so i.e. the structure is under what? I draw the opposite direction because action equal to reaction, same in magnitude, different in direction. So member AB is under tensile. But if you look at how the forces are applied, okay, the forces are applied along, right? Along the what? Along the neutral axis member. So you guys have done this before in terms of analysis in thrust analysis topic in 3SG3. Okay, I'm just going to bring it further. Okay, any questions so far? I don't hear much. Okay, a bunch of bars. Okay, right. So in general, okay, we're going to talk about two ways that we could design a structure. Okay, in general, there are two methods. Okay, two methods to design structures. Okay. So method number one, okay, is based on reaction forces. Okay, and method number two, okay, you include elastic deformation. Okay, so in general, okay, you most of the cases you can use method number one, okay, reaction forces. Okay, so reaction forces, I will call this as static analysis, using static analysis. Then we'll talk about what do we mean by static analysis. Okay, so for this case, right, in most of the cases, okay, we have to combine both methods. Okay, you have to combine both methods to carry out structure analysis. Okay, so when you apply both methods, you can solve structures in any configuration. If you just use reaction forces, sometimes you cannot solve the structure because it's statically indeterminate, which we will talk about it later. Okay, so let's look at method number one. Is we are going to look at reaction forces. And this is the most commonly used. Most of you have passed static and dynamics. This is straightforward for you. So in static reaction forces, okay, so what we have a beam, okay, and then we know the beam is under a load P, and we have a reaction P prime, right? So with this, right, all you need to do now is look at apply static analysis. So when we apply static analysis, what we mean is summation about forces in the y, okay, summation about forces in the x, and rotation about the z-axis. All of them are equal to 0. Okay. what you see over here is when positive, the forces in the y direction is going up. When the forces in the x direction is going towards the right is positive, and the moment rotation about the z in the counterclockwise are positive. Okay, so you apply static analysis to find reaction forces. Okay, so after that you apply stress. You apply stress in the axial direction is equal to force P divided by area, right? So over here, this is the area, right? So once you get this axial stress, okay, after you get this axial stress, you're going to compare. You have to make sure that the axial stress is lower than the stress allowable, okay, or the stress max of the material. Okay, so over here, these are your calculated stress. The allowable and the maximum is determined by the material mechanical properties. Okay, mechanical material properties. Okay, any questions so far? Anyone? Okay, I don't hear anything, so I'm going to proceed. So let's look at material mechanical properties. Okay, let's briefly look at what do we mean by material mechanical properties. So if we are going to go into stress strain curve, right? So this is a the stress strain curve of any material. Okay, not any. This is the most common type, especially for ductile material. Okay, so what we have over here, if I'm going to break this at this stage, over here, this is known as our plastic region. And this is our elastic region. Okay, so for this course, for structure design, right, you want everything in the elastic region. Okay, you don't go into the plastic region. The plastic region, you only do it in manufacturing processes. Because manufacturing processes, you want to bend the material up to a certain stage, right? So that you get the shape that you want, okay? Because not everything is designed in a square on a flat manner. There's always curve or make things longer. So we know, can someone tell me what is this point known as? What is point A known as? Anyone, please? And what is point B known as? Anyone?
Yield strength.
Yield strength, which is point what?
A.
Right, well done. So point A is known as your yield strength. And anyone, what is point B?
Ultimate strength.
Thank you. So point B is your ultimate strength.